Yeah, thanks for reminding me. Okay, so the lecture is being recorded. So let's talk about the exam that is next week. I posted a few moments ago the information about the exam. So let's look at that. I believe today is the 16th, so the exam is going to be on the 23rd. Let me share the screen here. All right, here we go. The exam is like last time for 3 hours, start around 6. And we have covered quite a bit of material, especially the last couple of weeks. There has been a lot of material that we covered. So it may be a little bit overwhelming. So I will try to see if I can help you focus a little bit for the exam. Okay, so we covered quite a bit of material, as we said. And there will be two questions. The first question is to modify the library. Okay, so you need to add new functionality. So the question would appear somewhat like this. There will be a new use case, and you will need to modify the use case, but actually you will need to use version 1.1, not version 1. Okay, you could use version 1 too, but I think 1.1 would be easier. So I will make that, I'll fix that. And the best way to prepare for that is to try your own new functionality. And you need to follow the same kind of arrangements that are in the implementation in version 1.1. So you need to see how to add a new command, how to get the requests go from the user interface to the library, how the library should carry out that task and then send the result back, and how the user interface should interpret that. So the best way to try it out would be to imagine a new functionality and then implement that. So that would be the best way to prepare for question 1. Question 2 will deal with a fundamental concept in object-oriented design. You will be given a problem, and then you need to refactor that to follow object-oriented design principles. So those would be the two questions, programming questions. And then there will be approximately 25 multiple choice, multi-select, true, false kind of questions. That would be the exam's structure, somewhat like the first exam, but the questions would be on the library, implementing something new, and refactoring a program that contains a few classes, and then using some of the refactoring techniques that we have covered in 8 and 9, like lectures 8 and 9. That is the exam. Now, so the focus should be for the programming questions, the library implementation, and refactoring. The multiple choice questions will cover pretty much everything. But spends more time on things that I emphasize tonight, whether it is this second question or the multiple choice questions. So you should focus on those kinds of things too. So are there any questions on the exam? All right, you might have some as we discuss things. I want to give an overview of some of the major concepts that we covered in lectures 8 and 9, mostly 9. I cannot cover everything. Actually, I don't want to repeat everything that is in the uh, PowerPoint or in the videos. So I'm going to give you uh, hints or the highlights of those concepts. So the first thing that I want to focus on is actually, oops, that's not the right way. The a refactoring rule. Okay, so this I consider to be one of the most fundamental refactoring or not fundamental object-oriented design principles that you should be very comfortable with, you should understand well, and that is replacing conditionals with polymorphism. So there is a video here, you must watch it, okay? If you haven't watched it, you must watch it. And let's see what it is all about. As I said, I consider this to be so fundamental. I mean, you have to clearly see what it is all about. I will give you the highlights here. Okay, so let me see if I can. Okay, we are trying to add new functionality to the library by adding things like periodicals, DVDs, and so on. But to help us focus, we are only considering adding periodicals. We could add other things without much problem if you know how to add one extra type of borrowable item. And we try to add periodical as a subclass of book or book as a subclass of periodical. Neither one is very attractive. They are pretty bad ideas. The reason is we could have something like this arrangement. Where is it? We could have a field called the book type. See, we can have a single class called book or periodical. Let's say it is book. And then inside that, we can have a field that says what kind of data we have. Is it a book or is it a periodical or is it a DVD, etc., etc. And if you don't like the name book for this class, you can call it something else, borrowable item or some item or whatever you like. But the idea is having a field inside this class that tells you what is stored. If this is 1, we are saying this is all about books. If book type is 2, we are saying it is a periodical. So if it is a periodical, we ignore the author field. If it is a book, we consider that author field, and so on. That is the idea. So when you create a book, we give the title, the author, and the ID, and we store all that. And we also store the constant book in book type, and book is 1. So we are remembering that we have stored a book in this particular class, in this object. And if it is a periodical, there is no author for a periodical. We give the title and ID, and then we store the constant 2. Periodical is actually 2 in this type field. Now we know what it is that we have stored. So for example, if you want to issue a book, you will look at the book type. I need to check out a book. It could be a periodical, it could be a book. So I will look at the book type at the time of issuing and then see if it is periodical, I will do one thing. And if it is a book, I will do some other thing. Let's not worry too much about what it is that we are doing exactly. That is not the point here. The point is that this issue method is behaving differently for periodical and book. So if it is periodical, it does one thing. If it is book, it does something else. So you get the correct result. This is exactly what is wrong with this kind of an approach. If the behavior of an object depends on a field, then it is time to refactor that. That is a bad design. You should not be having conditionals like this that switch on a field and then do one thing if that field is having a one value, and do another thing if it is having a different value. I mean, this is major behavior. I'm not talking about very simple things. This is major behavior. The behavior of issuing a book is different from that of a periodical. So in such a case, what you need to do is replace this conditionals with polymorphism. So we are seeing that we have a conditional, and we are going to say it's time to fix that design. So let me go ahead and show you the idea in on my whiteboard. Okay. All right. So what we have here is we have a class. I'm not going to talk about book or periodical anymore. I'm going to talk about the general idea. I have a class that I call sum class, and I have some method here, do something. And I have things like this. If I have a field, private let's say int, some field. If some field is 1, I'm not writing in Java, that's not important. Do in 1. Else if some field is 2, do thing 2. And so it goes. Else if some field is 3, do thing 3, etc., etc. That should be enough. So I have stored some values here, and I presumably am storing a value in some field that kind of tells me how to behave, right? when do something is called, I look at some field to decide how I should be behaving. And this could be a pretty major behavior of this object. So the behaviors are different depending upon some field. If that is the case, it is time to refactor this. How do you refactor this? Well, there are three behaviors in this example, right? Do thing one, do thing two, do thing three. So what you should do is, as a general rule, create this as a superclass, public. Maybe it's not a good idea for me to type here. I'm going to write using my pen. That may be easier. So there are three behaviors, right? So this is the first behavior. This is the second behavior, and this is the third behavior. So there are three distinct behaviors for my class, some class objects. So I'm going to create a superclass called some class. And we will create three subclasses, one for each behavior. I don't have enough space here, so I'm going to call them S1, S2, and S3. So S1 is going to behave like this, S2 is going to behave like this, and S3 is going to behave like this. So here I will have this method plus do something. So do something is a method that is probably abstract, or it need not be abstract, that you can decide later. And there will be an implementation of do something here. Sorry about the messy writing. Do something here. And do something here. Okay, so there are three types of objects, and do something here will do this. Do thing one, whatever code here you have, that is what do something here will do. Whatever is in do thing two will be what you have in this method, and do thing three will be the code that you put in do something. So instead of creating all objects of type some class, we'll be creating S1 objects, S2 objects, and S3 objects. S1 will behave like when some field is 1, S2 will behave as if some field is 2, and S3 will behave as if some field is 3. So what will happen is these conditionals are gone in these implementations. There is no conditional anymore in any one of these. So you simply have the code for do thing one, code for do thing two, do thing three. So we have replaced all these conditionals with polymorphism. So you will be creating some class, let's say X equals new S1 with some parameters probably. And you will be writing X dot do something. So X is of type S1, and when you call X dot do something, it will actually go here and it will do exactly this. And if it is S2, X dot do something will behave like this situation. And similarly for the case when this is S3. So this is essentially you have replaced, you got rid of all these conditionals, and you instead are using polymorphism, dynamic binding, actually, to call the appropriate behavior or to get the appropriate behavior. That is very fundamental thing that you should be looking for in your design. If you have conditionals like this, I'm not saying all conditionals that dictate major behavior. If it is something like, if the field is one set some other field to 2, and otherwise set some other field to 3, we are not talking about very simple things like that, but some things like issuing a book or a periodical. They are two very different behaviors. Then you should consider them to be two different types of objects. That is the essential idea. If two things behave very differently, then they are different types of objects. They deserve their own classes. That is the idea. This is a symptom of that disease or that fact, that you have different types of things to worry about, and you should be creating different classes. A book and a periodical behave differently, so you need different classes. So this goes at the very heart of object-oriented design, and I want everybody to understand this very clearly. Any questions?
Yes. Let's say like the public void do something method is in one of the class, like for example, in a book class, for example. Okay. It's a very big class. And when we extract this do method and spread them over 3 kind of classes, how it is going to be related to a book class then? I mean, is it going to extend the book class?
Yeah, like the book class, suppose it has something like do something, as you say, then if we did not have this kind of an arrangement, instead we had conditionals, then we will be putting behaviors for all types of books into one method. When we say books, they are not really always books, right? Books, periodicals, DVDs, blah, 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 all that stuff. Every kind of behavior is put into one. Now we are saying only one of those different behaviors is going to be in one class. The second part will be in a different class. The third part will be in the third class, and so on. So if you had 100 lines here, maybe 25 lines will go into the first one, 40 lines will go into the third one, and 35 lines will go into the third one. And we might have an abstract method here, or if there is something common among these, they will be extracted into the superclasses method. Questions? Does that make a little, does that help a little bit?
Yeah, but my question is this superclass, I mean, let us say like public void do something method, let us make it a class.
Do something is
so
a method.
basically we make it a class.
I'm sorry, let me interrupt here. Do something is a method.
Yes, when we refactor, it's going to be 3 classes. When
I can't hear you. Like I say?
Yes, so what I'm saying is when refract them, it is going to be 3 classes, right?
When?
Never mind, sir, I'll ask you later on. So.
It will be 3 classes.
Nathan, do you have a question?
No, I was just trying to answer his. It will be 3 classes.
It will be 3 classes. Yes. Yeah.
So when it is become 3 classes, are we going to extend some classes now, the super classes, by these 3 classes?
The thing is, whatever is common to all objects, all types of objects will be put into this superclass, right? There may be some method that is the same. For example, suppose there is a getter for the name of a item, then that will actually go into the superclass, right? So they will not be in the subclasses at all. The subclasses will have things that are different. I don't know if I'm answering your question.
Yep, that's okay. Yeah, thank you.
I guess by saying subclasses, you just answered the question. I think he was trying to say, do 1, 2, and 3 extend some class? Which you are saying yes, they are part.
Yeah.
They are children of some class.
Right. They are
Yeah.
subclasses of some class. Yes. Thank you, Rose. Yeah. Okay. So this, I think, is very fundamental. If you have behavior like this, then it is not really object-oriented design. Okay. Any other questions? Then couple of other things I wanted to point out from these 2 weeks. Oops. What am I doing here? Okay. All right, here. Let's go to lecture 8. I think we need to come back to lecture 9, but I don't want to miss this lecture 8. Or maybe, I think I forgot to put the transparencies in lecture 8. So give me a second. Let me go ahead and pull the
While you're doing that, I'm a little confused by the visitor pattern. Are we going to go over that today?
Yes, I'll go over that too. Yes.
All right, thank you.
Yeah, yeah. I'm getting PowerPoint up, so it's I don't know why it is not starting. Okay, it's beginning to show up on the screen. For some reason, I'm not getting lecture 8 up. So maybe I will look at we'll look at lecture 9. We'll look at the visitor pattern first, and then move on to other things. Okay, here. Where the heck is that? I'm not able to see that here. Why don't I? Why don't I explain the visitor pattern without using the PowerPoint? Okay, here, what is the visitor pattern all about? Okay, well, let's assume that we have a system like the library where we have the ability to issue books, etc., etc. And then we finished all our implementation, and now we are using the system. And at that point, we say, okay, I probably would like to add new functionality. Okay, so we have some system like the library. That is just an example. And we have a user interface. And we have been using this for a while, then suddenly decided, okay, I would like to add more functionality. Adding more functionality obviously means opening up all these classes and then seeing where to add new functionality, where to change stuff, etc., etc. Instead of that, in some restricted cases, I'm not talking about all cases, in some restricted cases, we can do it without opening up this. How? All right, and what are we talking about? What do you mean by those restricted cases? So what we are going to do is, imagine that in this system, there is a hierarchy of classes. So this is some superclass, and it has subclasses S1, S2, S3, S4, and so on. And suppose, that's a big suppose, it's a big restriction, we are adding new functionality that is somehow dependent on these objects. What do we mean? For example, in the library, we have a loanable item, things that can be loaned out, as in the hierarchy here. We can have books, we have periodicals, then we could, I could have laptops, I could have DVDs, and so on. So there is a hierarchy here. So that is what I'm talking about. Suppose we want to know, for example, for all books and periodicals and laptops and DVDs, whether they are checked out or not. I'm just imagining some simple functionality. For every book, for every periodical, for every laptop, for every DVD, I want to have a printout that says issued, 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 not issued, not issued, 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 that kind of stuff. Or the due date or some other statistics for every object. That would be an example of the kind of things that we are talking about. So things that essentially depend on everything in the hierarchy. If that is the new functionality that we want, so that we want to add that kind of functionality, not arbitrary things, very, very restricted kind of functionality, then we can use this visitor pattern. How do you use this visitor pattern? So to use this visitor pattern, you need to actually do some initial work, which is actually quite simple. So what we do is, to put in this visitor pattern, we have to work on that hierarchy. So we have subclasses, right? It is this hierarchy that we want to work on. We put in a method in every one of them, and that is called accept. It could be called something else, but it doesn't really matter. So every one of these classes has this accept method. Okay. And we have, so this is done at the time of initial implementation. So we are anticipating new functionalities to come our way eventually. That depends on the, that is dependent on this hierarchy. And so we put an accept method in every one of them. And we also create a visitor interface. The visitor interface, obviously, it is an interface. And it has a number of visit methods. Let me put these classes here. So it will have public void visit. All the methods will be called visit. The first one will be of type S. The second one would be public void visit S1. Third will be of S2. So every method is called visit. And the fourth one will also be called visit, and it will be S3. So there are 4 visit methods here, one for each class in this hierarchy. And we will also have a, maybe the facade, like the library facade, we will have a loop. There is a loop through the objects. So loop through all the objects in this hierarchy. That is the initial work that you need to do in your system. These accept methods are extremely simple, as you will see, and this is nothing but an interface, so you don't have to do anything except write all these method names in your interface initially. So there is very little work to do at the outset, all right? But then what do you do? What is the plan? The plan is this. I need to clear this stuff, otherwise I don't have space. So if you're talking about the library, we have the visitor interface. Maybe you can call it library visitor or something, or you can just call it visitor. And we have a hierarchy here, right? A loanable item with book, periodical, and DVD, etc. as subclasses. And what we do is, suppose we want to print for each item its due date. Then what we are going to do here is implement the visitor interface. We will write public class. I am not having much space here, so I'm going to call it something very short. Due date printer, due date P, implements visitor. So I create this due date printer. What it will obviously have is one method for each one of these classes, because that is what I have put in here. So I will have 4 methods. One for the superclass, one for each one of these. And I have a loop here, right? That loops through the entire catalog. And it will call the accept method. So for each object O1, it will call the accept method that is in this. So what does the accept method do? Well, the accept method, sorry, it should be actually O1 dot accept. For each object O1 here, I'll be calling accept on O1, and I will be passing as parameter this object. I'll be creating an object of type due date P, and that will be passed as parameter to the accept method. So this D is a visitor object, right? Due date P implements visitor. So this is a visitor, right? D is a visitor, and this, all these accept methods have just one line. All they will do is, they would look like this: public void accept visitor V. See, I just put the name of the interface. So it could be any kind of visitor. And if that visitor is V, I will call V dot visit this. So whenever the accept method of one of these classes is called, it will take this visitor object and call the corresponding visit method of that visitor object on this. So if it is the first type, if this is book, for example, then it will be passing a book object. It will be going to the book. It will be going to the corresponding method that has book as a parameter. If you are having a periodical here, if this accept method is in the periodical, then it will call the visit method with periodical as the parameter, etc. So whenever you want a new functionality, all you would do is create another implementation of this interface. So you need to create this interface once, put in all these accept methods, which are extremely simple. You can't really go wrong in writing this kind of stuff, right? Just one line, no conditionals, and it is the same. You write it in one, you copy and paste it into all the other classes. That's it. It's the same thing. So that's amazingly simple. There is hardly anything to go wrong here. Whenever you want a new functionality that is dependent on every item in the hierarchy, you create a new visitor. And
Professor,
the loop here, sorry?
Sorry, I just had a quick question. As I'm thinking about this, would it be generally considered a bad idea in your visitor methods to reference fields that only exist in the subclass?
It is a bad idea for the system to expose all the references. It is a bad idea to give these actual references. So you might actually want to copy those things and then send the copies.
No, so maybe I didn't explain my question very well. So we've got book and we've got periodical as subclasses, let's say, right? So in my visit methods, in my visitor interface, if I implemented a class that corresponds to periodicals, but not to book, to use.
You can't do that because this visitor interface has a visit method for every type of every type that is present in this hierarchy, right? So there is one for ownable item, one for book, one for periodical, one for DVD. So you can't escape that. You might do nothing in that particular visit method. In a specific implementation, you might say, I'm not going to do anything for periodical objects. You could write public void visit periodical P and do nothing inside. That is okay. But since you are implementing an interface, you have to have every method here implemented here. Does that make sense? I have 4 classes here, so there will be
I don't know that
4.
I'm explaining my question very well. I'm going to type some pseudocode in the chat, and you can continue if you want, and then we can just look at the pseudocode when it's convenient.
Yeah, sure.
I don't want to hold up the
Yeah.
class.
Okay. Okay. Yeah. Please type it in. I will look for that. Any other questions on this? Okay. But you can't do arbitrary modifications to the system using this. This only works for a small type of changes. So don't imagine that any change that you can have in the future would be accomplished through the visitor interface. No, that is not possible. It is only if you are looking at all the items in a specific hierarchy and work on that. And it also has limitations. If you add a new class here, the visitor interface is already done, so you can't really accommodate that new class in this interface, in this pattern. So that is a drawback. I mean, everything has a drawback. And as I said, it is not a great idea for you to expose all these references to the outside world. So you might want to copy things and then send those rather than send the original objects. Any other questions? Okay, then let's see here. I mean, the other things are actually quite much simpler to explain. So let me go ahead and see if I have that. Other PowerPoint available. I think yes. Okay, so maybe I do. Yeah, all right. Yeah, this can be shorter, I think, a shorter discussion, I think. So, but there are important lessons here as well. So, okay, here, in this particular example, we are having fines charged for late returns of books. So if you have such a situation, then our pseudocode might be looking like this. You need to, when you return a book, you need to compute the fines. So computing the fine is, of course, data processing, but still it is mostly financial calculations, which don't quite, I mean, which is not of the same kind of code as getting references to books and then doing something on a book object, etc., etc. We are actually saying how many days is this book late? What is the book policy for computing fines, etc. So putting this in the middle of return book could be very non-cohesive. So what we do is we put code like this, which is dealing with all kinds of details that are not really central to returning a book, in a separate method. So if you have a sudden change in the tune of your, I don't know if that is the right word to use. If you're suddenly seeing that you are doing something different, you find that you need to explain this to somebody, what you are doing suddenly, then it is a good idea to consider putting code like this into a different method and call that code from the original. So this is extracting a method. And then you would also see that you would do things like, so that is one thing. We create a method called compute find. Instead of putting all this in the middle of the return book method, extract this as a separate method. The second part of it is that if you look at this, if this is in the library class, it is using a book object and using the fields of book, like the find field, whether there is a hold, what is the due date, etc. So we are doing all this computation of find on a book in library all the time, looking at the fields of the book class. This means you are importing data from the book class into library. Instead, you should simply move this whole method into the book class. So that is the second lesson in this particular case. Move the whole method into the other class. So now compute find is in the book class. It doesn't really require any book parameter because it is on the current book, and you are only dealing with things that are in the book class. So everything looks much more cohesive than it was in the, or actually less coupling as well. You have avoided all that coupling from library to book because you are less dependent on the fields of book in library. So that is the refactoring rules of extracting methods and moving methods. But I think the replacing conditionals with polymorphism is even more central to object-oriented design. I'm not discounting that. I'm not saying that these are unimportant or anything. They are also very important. Then maybe a couple of things more here. Give me a second. Let me find. Yeah, I'm not spending. This probably will take 5 minutes. I will ask you to watch the videos, but I just wanted to.
Can you go over slide 19 really quick?
In which in this slide, in this one?
Yep. And just explain that a little bit. It sounds kind of confusing.
Okay. Here? Are you talking, oh, sorry, you can't see this, right? I mean, hold on. I'm looking for the correct window to share. So bear with me, please. Yeah, this is the one, I think. Are you talking about this one? Are you,
no. Can you go down one more? Yes, this one.
okay. Yeah.
I think it's.
I will come to this in a second. Let me give the context before we get there. All right. So what we are doing is using generics. Catalog and member list are very similar in functionality, but the only thing is, I mean, there is a remove book in catalog, but not in, there is no remove member, but otherwise they're pretty much the same in terms of the functionalities of the methods. So what we can do is we can use a generic type. So we can have a list, a custom class called item list that uses the, so what we are going to have is a class called item list that has the type of the item to be stored. So this T will be either a book or a member. And I will be having methods with the generic names like add, remove kind of stuff, or add, search. I'm not saying, I'm going to say whether it is book or a member or anything. And I will be using this letter T, which could either be a book or a member. So there are two things I need. I need to know what type I should be storing in item list. The second thing is, what is the key type? Because in general, the keys could be different for different types of items. We happen to have string in both book and member, but what if one of them is int, the other one is a string, or that kind of stuff. So we need two parameters. We need to know what the type of item to be stored and what is the key type. Those are the two parameters. But if you put it like this, there is no relationship between T and K. So we could be having funny things like we could be putting transaction, and then the second one could be absolute nonsense like book. I can't prevent somebody from writing like this, you know, item list. This doesn't make any sense. Right? Again, people will be able to write code like this. That I want to prevent, right? There has to be some kind of relationship between the two things I am shipping. If the first one is transaction, the second one cannot be book. If the first one is book, if the type of item that I'm storing is book, then it makes sense if the second one is string, right? So I need to constrain what is allowed when people use this class. So there has to be some kind of relationship implied between these. So what we are going to do is we have a custom interface called matchable, and it has the type of key. It will check whether a key that you give is, or an object that you give has this key, as the key, right? This other as the key. So this is the type of the key. So this is the type of the item, and this is the type of the key. What is the relationship between these two? And that is actually here. Item list T extends matchable K. Okay, this is a bit mysterious. What does it mean? Well, item list will accept two parameters. The first one is all this, right? And there is a comma here. So look for the comma here. So this is the first parameter, and it is T. There is some qualification of T for T. The second one is K. And the rest of it is actually the relationship between T and K. How are they related? Whatever you pass in as the first parameter should be extending, which means either extending or implementing the second one. If matchable is an interface, then whatever you pass as the first parameter should be implementing that interface. if matchable is a class, then whatever you pass in as the first parameter should be extending that class. That is the meaning. So if I pass book, comma, string, let me write here, item list, book, comma, string, I'll be creating a new item list here on the right-hand side. What would Java do for me? Java will associate book with T. T is book. And it will associate string with K. So K is string. Then it will check, is book implementing matchable string? Because K is already string, T is already book. That is what I specified, right? So Java compiler is going to check, does this make sense? Is book, the first parameter, implementing matchable with string as a parameter? So I have actually modified my book class to implement the matchable interface. So this works. There is no compilation error here. On the other hand, if I wrote something like integer, then K is integer, T is still book, and Java will check, is book implementing matchable with integer as the parameter? Well, book implements matchable with string as a parameter, not as integer. So this doesn't work. So this will be a compilation error. So I will not be able to pass in things like transaction, comma, book, because transaction doesn't implement matchable book. Or yeah, right. Yeah, so only meaningful things will be actually allowed. Does that make sense? Java generics is really hard to understand. Any questions? Okay, finally, we have this state classes, which we will look at in earnest after the, I mean, there is some little bit of it in the videos and for this week and next week, but we will be looking at it in earnest after the exam. So, but there will be some exercises on it tonight. Okay. Any questions? It was a long lecture. So do you have any questions for me? Let me see if there are any chat questions on the chat. I didn't find any. I hope your projects are all going okay. Are there any common questions about the project that I can answer now? Otherwise, of course, I'll be chatting with you on the project when I come to your rooms. Are there any questions that I can answer now? Okay, let me stop recording.